Okay, students, good morning everyone. What did we study in the last class? Yes, can you all hear me? Am I audible to you all?
Yes, ma'am.
Okay. Yes, ma'am. Okay. So, yes, just can anyone tell me what we studied in the last class? What did I teach in the last class? What did I teach in the last class? Very nice. Yes, yesterday what I thought, why does the object sink or float? Not yesterday, day before yesterday, right? Are you all active in the class or just log in and doing whatever you all want? Students, yes, tell me, did I not teach why does the object float and why does the object sink?
Yes, ma'am.
Then answer no, why are you dumb like this? Sitting dumb? Okay. So yesterday we understood why the objects will float or why it will sink. Now we'll see one more new condition of that and we'll study Archimedes principle today. Okay. So to understand this principle, we will go and do one small activity. Okay. So for that activity, take any string. Spring, you all know the spring, and the spring will be having a reading board over here. Means measurements will be over here. There is a needle and it will show you how much it strings, how much it is suspended down. Have you all seen such springs?
Yes, ma'am.
Okay. So now what I'll do is, let me take a spring. For this spring, I will attach a stone. Okay, I have attached a stone for this spring. So what will happen when I attach this stone to the spring? The spring starts stretching, right? It stretches like this. So when it stretches like that, what we need to do is note down the length. Okay, whatever is the length, we will note down the length over whatever is shown by the needle, that reading we will note down. Okay, so after that reading, what we will do is the same thing. I will put this into a container which is containing water. Okay, slowly I will put this string into the container containing the water. So when I place it over here, what we can see some changes in that. The changes is that the string's elongation. Now the string is fully elongated. As it goes inside the water, the elongation starts decreasing. Okay, slowly the elongation start decreasing. So still more I will start immersing it, and completely when I immerse the stone till here, we can observe the change in the length. After immersing this completely, again I will note down the length of the string. Okay. So now suppose let the length of the string be, let original length be x we will take. Okay, that is without the water container. Now when I place this, that time I will get the length as something x minus 1. Okay, this x and x minus 1 is just for your understanding. Okay, don't take it very seriously. Just to make you all understand, I have taken original length as x, and after putting it into the water, the length becomes x minus 1. So what has happened to the elongation of the spring or the length of the spring? Is it decreased or increased? It has decreased or increased, students? Before it was x, now it has become x minus 1. So what has happened for the elongation of the string? Is it decreased or increased? Please answer. It has been decreased. So it has decreased, right? Now can you think over it? Yes, okay, decreased. It has decreased. Good. Now the question arises to our minds that the weight of the stone will remain same. Either I put it in water or either I just hold it like that outside. The mass of the stone is same. But when I put it in water, the elongation has decreased. Means what? The weight has decreased somewhat. The weight has become less. It has decreased or no, we don't know, but the weight has become less, right? So only the elongation has become little less. Now, what is the reason? What will happen if I after putting this in water? So, as we have studied in the last chapter, that is buoyancy. What is buoyancy? Buoyancy is the upward force, right? So when this stone will be entering into the container on the top, then in the between, and then it reaches the bottom. So what will happen? This water will apply buoyancy or it will apply upward force. So what will happen when it is applying upward force? This stone will try to move little upward. So what will happen for the length? The length decreases. This is the reason why the length has decreased. Now this you all can try it out your home. If you all are having a spring in a home, for that spring just tie any object. Yes, what? Rashmi, yes, any doubt? Okay. So if you all have string, after the class, try it out. Tie any object, little heavier object you take and tie. Yes, what you want, ask fast. Simply don't create disturbance. Yes, I saw Rashmi, your mic was on. You want to ask anything? Ask. Okay. Better all of you will keep your mics on mute and better ask it in text only. Or else simply it is a disturbance for everyone. Okay. Okay. So now what will happen? It will elongate. Why? Because of the upward force. So based on this, there was a scientist named as Archimedes. So he gave one principle. He gave one principle. So what does his principle say that is Rashmi, mute your mic. Okay. So what his principle tells is that when an object is immersed, okay, so suppose now this is our object, right? When an object is immersed fully or partly in a fluid, it experiences a upward force which is equal to the weight of the object. Okay, I repeat, when an object is immersed in a liquid, either partly or fully, it experiences a upward force, and the upward force is equal to weight of this object. Okay, so now suppose the weight of this object is W. Okay, so when it is W, so this upward force will be equal to this value of upward force, whatever we will get over here, and the value for the weight of the stone, both will be same. So that is what Archimedes principle states us. I will repeat the statement, listen carefully. Any object immersed in a fluid, either partly or fully, it will experience an upward force which is equal to the weight of the object. Okay, so this principle helped in designing many things. Okay, have you seen the ships which are made up of iron? They are made up of some iron objects also inside. The submarines, the ships, you all have seen, those are in such large area. Do they sink? They float, right? Even after having so much of weight, they float, right, on the water. For what is the reason? That is the weight of the ship and the upward force with which the ship is pushed up is equal, then only it can float. So this principle helped many things. This principle helped in designing the ships and also designing the submarines and this principle is also help to check the quality of the milk. How do we check the quality of the milk? We use a lactometer, right, to check the quality of the milk. In the lactometer also the same principle is used. Okay, lactometer works with Archimedes principle. Now, why do we use lactometer and what is the use of the lactometer? Lactometer is used to check the quality of the milk. Okay, so these are some applications of Archimedes principle. Okay, so did you all understand Archimedes principle? Okay.
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Okay. So now we'll move on to the next and the last topic of this chapter. So the next and last topic of this chapter is relative density. Okay. Now I have explained the meaning of density in my last class, correct? So what is density? Density is mass per unit volume, correct? Is it correct? How do you define density? Yes, can anyone define what is density? Mass, yes, mass per unit volume is termed as density. Now we will study what is relative density. Okay, so relative density is you take the density of any liquid. Okay, now for example, I have two liquids, liquid A. Off your mics. Off your mics. So now I am having liquid A and liquid B. Liquid A is you can take oil. Okay, first liquid is oil and second liquid is water. Okay, now I will calculate the density of oil and also I will calculate the density of water. Okay, so when I compare the density of oil with respect to water, then it becomes relative density. See, I will repeat once more. If I compare the density of any liquid with water, then that is termed as relative density. Okay. So now I'll tell you always the density. Okay. Density of water is 1000. Density of water is always equals to 1000. So what can be the SI unit of density? Can anyone tell me? What is the SI unit of density?
Mass per unit.
I am not asking the definition of density. I am asking SI. Listen my question carefully. I am asking SI unit of density. Density definition is mass per unit volume. How will you, what is SI unit? For mass, SI unit is kg, right? In the same way, what is the SI unit of density? Mass per unit volume is, see, mass per unit volume is the density definition. See, in case if you all don't know the SI unit of any quantity, how you can find out? I'll tell you. Now, what is the formula for density? D is equals to M by V. M is what? M means mass. So, mass is measured in which quantity? Kgs. So, kg divided by, next what I am having? Volume. Volume is measured in meter cube. Volume means all three dimensions you measure. So, SI unit of volume is meter cube. So now when you divide this, you will get the SI unit of density, that is kg per meter cube. This is on denominator. Going on top, this becomes -3. So the SI unit of density is kg per meter cube. So here I write kg per meter cube. Okay. So the density of water is 1000 kg per meter cube. Also you can write it as 10 raised to 3 kg per meter cube. Now you take the density of any liquid and compare it with the density of water. So that density will become relative density. Understood? What is relative density?
Yes, ma'am.
Okay. Now here also we need to remember one formula, that is relative density is equals to density of the liquid or the substance, density of liquid or it can be any other substance, divided by what? Divided by density of water. Okay, so this is the formula for relative density. Relative density is equals to density of liquid or any substance divided by the density of water. Now, how can you define the relative density? So, relative density is defined as the density of any substance or object when compared to the density of water will give you the relative density. Okay. Now one more question arises. Now what will be the SI unit for relative density? First I ask you one question. First tell me, will relative density have SI unit? Will relative density have SI unit? Think and tell me. Now don't use your mics and give me the answer. Give it in the chat section.
No, ma'am. No, ma'am.
No, relative density will not have SI unit. Why? Because what will be the SI unit of this density of any substance is again kg meter cube divided by what is the SI unit for density of water, again it is kg per meter cube. So this cancels. So relative density has no SI unit. Okay, understood what is relative density? Okay, students, did you all understand what is Archimedes principle and what is relative density?
Yes, ma'am.
Okay, so
Yes, ma'am.
okay, so now
Yes, ma'am.
one example problem is given in your textbook based on relative density. We'll do that. Okay, so first I'll read out the problem, listen carefully and we'll solve it. Relative density of silver is 10.8. Okay, and the density of water is 10 raised to 3 kg per meter cube. What is the density of silver in SI units? Okay, did you all listen carefully the question or should I read it once more? Okay, I'll read it once more. Listen. Relative density of silver is 10.8. Let me write. So, what is given over here? Given is relative density of silver. Okay, how much it is? 10.8. Okay, 10.8. And then next, the density of water is, so density of water is also given. It is 10 raised to 3 kg per meter cube. Next, to find what they have given us to find in this problem, they have asked what is the density of the silver in SI unit. So I have to find density of the silver. So it is to find is density of silver. So which formula I use to solve this? Which formula should I use to solve this? Tell me the formula.
Ma'am, density is equal to mass per volume.
Density is equals to mass per volume. But mass and volume is given to me over here. No. Then how can I use that formula? Think and tell me. What I need to find is density of silver. So density of
Density of substance upon density of water.
yes. So that we will use the formula of relative density, which I had written just now. What is the formula? Relative density is equals to, I am writing all this in shortcuts, okay? Relative density is equals to density of silver divided by density of water. Right? This was the formula of relative density. Okay. So now relative density is given. Yes, it is given. The next density of water. This and this is given. But I need to find this. So this is not given. I need to find this. So what I do? I will cross multiply this. So I will get relative density into density of water will give me the density of silver. So what is relative density? Is it given to me in the sum? Relative density is given. Yes, answer me. Is relative density given? Then density of water also is given. Then when I multiply both, I will get density of silver. So what is relative density? Relative density is 10 into 8. So this is not visible, right? Okay. So relative density is 10.8 into density of water. How much it is? It is given over here. So it is 10.8 into 10 raised to 3. So answer is what? 10.8 into 10 raised to 3 is the same thing only. 10.8 into 10 raised to 3. So what is the SI unit? What should I write the SI unit over here? Tell me, students.
Kilogram per meter cube.
Yes, it is kg per meter cube. So this is the answer. That is density of silver is 10.8 into 10 raised to 3 kg per meter cube. Okay, such kind of problems can be asked. And before this also few problems on this I have solved in the recorded class. Okay, so this completes the gravitation chapter over here, students. Okay. So just wait a minute.
Okay, ma'am.
Okay, just wait a minute. Wait a minute.
Okay, ma'am.
Okay. So today what I'll do is today I will send you all the questions. Okay, I'll send the PDF in the notification. What you'll have to do is you should write all the question and answers in your fair book. Okay, only important questions I'll be sending. Find the answers for those questions and write it in your fair book. If any doubt in this chapter, you can ask it now only, because in the next class I will start with a new chapter.
Okay, ma'am.
Any doubts?
Okay.
Any doubts?
No, ma'am. No, ma'am. No, ma'am. No, ma'am.
Okay.
No, ma'am.
Okay. So this chapter completes over here. In the next class, we will start with some new chapter. Before that, if go through this chapter, write all the question answers. See whether if you are having any doubt. If you all are having, we'll clear it out in the next class. If not, we'll start with the new chapter. Okay?
Bye, ma'am. Okay, ma'am.
Okay, okay. So we'll wind up the class over here. Bye bye, students.
Bye, ma'am.
Okay.
Bye, ma'am. Bye, ma'am.
Okay, okay, bye.
Bye, ma'am.